say that I give the length of the string L, 1 meter. The length of the string, let's say that I give either the height or the angle. I will say the angle of release, let's say that it's at 30 degrees, so with respect to the vertical. The question can be find A, the speed when it's at the bottom, which is here, or B, find the speed when the object is, let's say, halfway through, 15 degrees from the top. So 15 degrees. This is an example when we have the pendulum. So this is the pendulum. So if we have this object, let's say that I release from here, from 30 degrees. And I release. So it will go back and forth like this. We'll move the pendulum. All right, we use here one of the three theorems. Since we are looking for velocity, we have to use one of the three theorems. Which one you think that will be the appropriate one?
Third one.
The third one, because no non-conservative force and no forces are given explicitly. So we use the third one. We can use delta E equals 0 or EI is equal to final. So we usually will use EI and E final when we know exactly at what positions are the objects. For example, here I know that this is the lowest level and can be my 0, and this is my highest level. Now, there are situations where you have, for example, an object coming from here to here. And I say this will go down from here to here, let's say 3 meters. And the angle, whatever, I give the angle. 3 meters. You know, but unless you say that this is your lowest position, you can use EI is equal to final. But if you don't see where this ends, because you know that it's a 3 meter down, but you don't know what is the lowest position or whatever, you can say, instead of EI equal to final, it's better to use delta E equals 0. This is the difference in situation. So sometimes it's better to use this because you see the variation. Sometimes it will be better to use this because you know what is for certain, what is the initial and final position. Let's say this ball go from 3 meters to 0, to the ground. You know here that this is EI and this is E final, but you know this position. So if you don't know this position, sometimes it's better to work. And I said, you don't know what is this, and I ask, okay, this go from here to here, 3 meters or 2 meters. It's better to use the change in potential and mechanical energy equal to 0. All right, I will tell you in an example later. Let's do the pendulum. In order to understand the pendulum problems, the first thing you need to know is we have to use the third theorem, EI is equal to final. And now we go by inspection. We release from here. If we release from here, at this point, what type of energy have the object? Potential or kinetic? Potential. You can see that it's not moving. So you will say EI is only made of what type of energy? Potential. And what type of potential energy? There are two types of potential energy we learned so far. Gravitational and the spring. Of the two, which one is the one that has the object now? Gravitational. And what is gravitational potential energy? mgy. So by inspection, I will say that mgy initial equal. You go to the second point, or the second stage, and it's here, at the lowest point. If it's at the lowest point, the object will have potential energy with respect to this point, not with respect to the ground, but with respect to this point. So at this point, because it's at the lowest position, there is no potential energy with respect to that point. But is it moving? since it's moving at the lowest position, the object has kinetic energy. So at the end, the total mechanical energy is made of what type of energy? Kinetic. So what will be the formula? 1/2 mv squared. We can see here the mass cancels out, and v is the square root of 2gh or 2gy initial. We don't have y initial. If I give y initial, great, but I didn't give how much is this height. But I gave the length of the chord and the angle from the vertical. So if you do this diagram, this is my length, this is my angle. When this goes from here to here, the length is the same. The length doesn't change. So if I just trace this here, my height, which is this height, will be the total length minus this side. Is that correct? So if we subtract to the total length this side, so to the total length, we subtract this, we will get this. So what will be, if I call this L prime, let's say, from here to here, so I will say that my height y on the pendulum will be the total L minus this side. But on the right triangle, if this is the hypotenuse, this will be the adjacent side. What will be the adjacent side? Cosine. So will be L prime, which is this, minus cosine theta, which will be, L, this will be L prime, will be L cosine theta, which is this. So L cosine theta, if I put it here, the height always will be L1 minus cosine theta. This is if the angle is given from the vertical. Always the way to find the height in the pendulum, is L times 1 minus cosine theta. So knowing that, we come here and we can find V. V will be the square root of 2g L1 minus cosine theta. Remember this formula, and this only is applicable for the pendulum. So we can get V. Any question? So the steps here, the only steps difficult is to find that, if you don't remember, you just memorize. L times 1 minus cosine theta will be the formula to find the height in the pendulum. And that's B. So if you substitute the value now, you can get what will be the velocity at the lowest point. If I give the height, will be just the height that I give, the square root of 2g, that height. But many times it's not given the height, it's given the length and the angle. All right, in part B, we go again by inspection. We have to use, in part B, normally, the method here, the first thing is to choose which theorem, first, second, or third, because we are using or solving the same problem, have to be the third. So again, you start with the EI is equally final. I am asking now to find the speed when it's halfway through, which is 15 degrees, or in the other side 15 degrees. So you can start from here, because the energy conserved anyway, the mechanical energy, or you can start from the initial point, it doesn't matter. So I can say, starting from the